this class, today we are going to learn about hybridization in much more detail. In the last class, we have learned about the hybridization of carbon in methane molecule. In this lesson, we will see how actually hybridization concept is understood and how it helps us to understand the hybridization in different molecules. To understand hybridization, you need to understand valency bond theory. So I am not going into the details of valency bond theory because the video becomes very big. Okay, I will explain key concepts of valency bond theory. Okay, to understand the valency bond theory, first you need to understand what is bonding. In class 10th chemistry, there is a lesson called covalent bond. In that lesson, bonding is detailedly explained. So we will pick up that topic to understand what is bonding. Bonding is nothing but when two orbitals combine together to form a link. Okay, a link here what we call it as bond. Two orbitals combine together to form link, which is called bond. Okay, to gain, the key important point here, to gain what is it? It is stability. To gain stability. So to gain stability, to understand the bond formation and the bond getting stable, you need to understand the concept of orbital formation and how orbitals combine to form different types of bonds. So this topic is dealt in chemical bonding lesson of class 10th. So now we will go in detail about the bonding process. So here we have four types of orbitals. How many types? Four types of orbitals. These four types of orbitals combine to form different bonds. So the first type of orbital is s orbital. Second is p orbital. Third is d orbital. The fourth one is f orbital. So we have four types of orbitals: s orbital, p orbital, d orbital, and f orbital. Now in class 10th we will discuss only about these two orbitals. In higher classes we will study about d orbital and f orbital. Okay. Now let us study about s orbital. S orbital, its shape is spherical. Let us see how this orbital looks like. Okay, this is x-axis and this is y-axis, x and y, and this is the z-axis. Okay, now we have to draw a circle in the center, and this is a sphere. Spherical shape lo s orbital అనేది ఉంటుంది. Okay, to give you a little depth to understand this, I am drawing a little bit shading to understand how an s orbital looks. This is s orbital. Okay, say suppose this is 1s. Okay, according to the Euler method, we have the 1s, 2s, 3s, so on. Okay, 1s orbital will have least energy, 2s will have a little higher energy, and 3s will have more higher energies. Okay, this is, and one more point you need to remember here, s orbital shape will be smaller compared to the 1s orbital is smaller than 2s orbital, and 2s orbital is smaller than 3s orbital. That means 2s is bigger than 1s orbital. So as the number increases, the orbital size also increases. That point you need to remember. This is s orbital. Okay, now second one is p orbital. P orbital is divided into three types. It is divided into three suborbitals. Okay, one is px, second one is py, and third one is pz. Okay, these are called suborbitals. Okay, the shape of these orbitals is, okay, shape of p orbitals is dumbbell shape. Okay, let us see how p orbitals look like. px, py, pz orbital. So draw coordinate axis, and this is x axis, this is y axis, and imaginary z axis will be crossing the origin at an incline. So here the electron cloud is on the x axis. So this is the px orbital. See, the entire cloud is on which side? On the x axis. So this is the, now 2py, again x axis and y axis. Now here the cloud will be on the y axis. Okay, here the cloud will be on the y axis. So here this is how you need to, so this is z axis. Here also we have z axis. Okay, now 2pz, 2pz I am drawing somewhere over here. Okay, pz axis, x axis, y axis. X and this is y. This is pz axis. So these are the 3p suborbitals. These are the 3p suborbitals which actually combine to form bonds. Okay, understood? Now capacity of orbitals. S orbital will have a maximum of 2 electrons. P orbitals have a maximum of 6 electrons. How you get 6 electrons in p orbitals? P orbitals will have 3 suborbitals. Px orbital will have 2 electrons, Py orbital will have 2 electrons, and Pz orbital will have 2 electrons. So 2 electrons plus 2 electrons plus 2 electrons, total 6 electrons. So this is the capacity of the p orbital. Now you have understood about orbitals. Now orbitals combine to form bonds. Okay, now let us see how bonds are formed. To understand the bonds, we need to understand two types of bonds. First bond is sigma bond. Next one is pi bond. Okay, the word sigma, okay, is denoted by a Greek alphabet. Okay, this is the symbol for sigma, and for the pi you have the mathematical symbol pi. We represent it as pi. Okay, pi bond. So this is equal to this and this is equal to this. So these two types of bonds will be formed. Okay, how a sigma bond is formed? So we have how many orbitals? We have s orbital and we have p orbitals. Now if you see s orbital, one s orbital can combine with another s orbital. So this is 1s and this is also 1s. Orbitals, when 1s orbital is combined with another 1s orbital, it forms a bond like this. Okay, this is the combination of 1s. So here it is a sigma bond. Okay, the nucleus of 1s and the nucleus of another 1s will combine to form. Okay, here this is the nucleus of one and this is the nucleus of others. So this is called S sigma bond. Okay, this is first sigma bond. Second sigma bond is 1s orbital is combined with 1 p orbital along the x-axis, px orbital. Okay, when these two combine together, okay, a new orbital will form. Okay, which is this is 1s and this is p. So this is sp sigma bond. In this orbital, 1s orbital and 1p orbital are involved. ఇక్కడ ఏంటంటే ఒక s orbital ఇంకొక p orbital తోటి ఇన్వాల్వ్ అయ్యి ఒక హైబ్రిడైజ్డ్ ఓకే ఆర్బిటాల్ని జనరేట్ చేసింది అన్నమాట. దీన్ని ఈ బాండ్ ఏమంటారంటే sp సిగ్మా బాండ్ అని అంటాం. ఓకే, థర్డ్ టైప్ ఆఫ్ బాండ్ 1p orbital will combine with another p orbital. Okay, so px to px to form a strong sigma bond. Okay, this is called pp sigma bond. Okay, this is called pp sigma bond. Okay, so this is ss sigma bond, this is sp sigma bond, this is pp sigma bond. So these are the three types of sigma bonds which are important to understand the concept of bonding. Now here all the sigma bonds are strong bonds. So sigma bonds are strong bonds because the overlapping is happening along the internuclear axis. Along the internuclear axis. What is the meaning of the word internuclear axis? ఈ న్యూక్లియస్ కి మధ్యలో కానీ మనం ఒక ఇమాజినరీ లైన్ డ్రా చేసుకుంటే ఆ రెండు న్యూక్లియస్ మధ్యలోంచి ఆ లైన్ వెళ్తుంది. ఆ లైన్ గుండా ఈ రెండు ఆర్బిటాల్స్ వచ్చి కంబైన్ అవుతాయి అన్నమాట. సో ఆ విధంగా జరగడం వల్ల డ్యూ టు దట్ ప్రాసెస్ ఆఫ్ overlapping of orbitals along the internuclear axis, the sigma bond is always a strong bond. Okay, so sigma bonds are difficult to break. It needs more energy to break a sigma bond. Once a sigma bond is formed, it is difficult to break. It takes lot of energy. So అందుకే మనం ఏం చెప్పొచ్చు అంటే sigma bond is a strong bond comparative to pi bond. So hope you understood this part. Now moving to the pi bond. Pi bond, which is also called pi bond. Pi bond is generally a weak bond. So in pi bond, okay, py orbitals overlapping is observed, or pz overlapping of orbitals is observed. ఇవి ఎలా ఉంటాయో ఒకసారి చూద్దాం. ఓకే, let us take one py orbital, this is py, and another py orbital, Now when these two py orbitals combine together, so how they form? Along the this is the internuclear axis, so they cannot combine along the internuclear axis. They will combine above the axis and below the axis. Above the axis and below the axis. Due to this, what happens? The pi bond is always not a strong bond comparative to sigma bond. So pi bond is a weak bond. After overlapping, the diagram becomes like this. This is the internuclear axis. Okay, above the internuclear axis you will see an electron cloud, and below the internuclear axis you will see an electron cloud, which is the py pi bond. Okay, this is how the pi bond is on. ఈ షేప్ లో చూడండి, ఇది ఒక బనానా షేప్ లో ఉంది. ఓకే ఓకే ఇది ఒక బనానా టైప్ షేప్ లో ఉంది కాబట్టి somewhere in some point we also considered in the old classical chemistry it is represented to a banana type of bond. but not exactly a banana bond, but this is a banana shaped type of bond. So it helps us to remember a pi bond. So pi bond always forms above and below the internuclear axis. Okay, అది చాలా ఇంపార్టెంట్ పాయింట్ అన్నది గుర్తుపెట్టుకోండి. సో ఇట్ హ్యాపెన్స్ అబౌవ్ అండ్ బిలో ద internuclear axis. These are the two types of bonds which are very essential in understanding the concept of bonding and also hybridization. Now this is the important question. Okay, ఇది 10th క్లాస్లోని చాలా ఇంపార్టెంట్ కాన్సెప్ట్. ఇది కెమికల్ బాండింగ్ అండ్ హైబ్రిడైజేషన్ బేస్ చేసుకొని అడిగిన క్వశ్చన్ ఉంది ఇది. ఓకే, ఐ రీడ్ ద క్వశ్చన్ ఫర్ యూ. ఎక్స్ప్లెయిన్ ద ఫార్మేషన్ ఆఫ్ బెరీలియం క్లోరైడ్ అండ్ బోరాన్ ట్రైఫ్లోరైడ్. ఓకే, బెరీలియం క్లోరైడ్ BeCl2 అండ్ బోరాన్ ట్రైఫ్లోరైడ్ BF3. సో ఈ వ్యాలెన్సీ బాండ్ థియరీని యూజ్ చేసుకొని హైబ్రిడైజేషన్ కాన్సెప్ట్ని యూజ్ చేసుకొని మీరు ఈ రెండు మాలిక్యూల్స్ యొక్క స్ట్రక్చర్, దాని తర్వాత షేప్ అండ్ వాట్ టైప్ ఆఫ్ హైబ్రిడైజేషన్ ఇందులో ఉంటుందో మీరు ఎక్స్ప్లెయిన్ చేయాలన్నమాట. సో ప్రైమరీలీ టు గివ్ యూ అన్ ఐడియా, బెరీలియం క్లోరైడ్ will have sp hybridization and boron trifluoride will have sp2 hybridization. ఓకే, ఇది ఇప్పటికే వీడియో చాలా లెంగ్తీ అయిపోయింది. సో we will see this concept in detail in the next video. Okay, that's all for now. If you like these videos, okay, please subscribe and share it to your classmates and your friends. Thank you. That's all for today.